Welcome learner, Department of Collegiate and Technical Education has provided us online teaching and learning platform through LMS. Under this program, we take up the course PCB Design and Fabrication Lab for 5th semester Diploma in Electronics and Communication Engineering students. Under this Unit 1, Introduction to PCB, under this Session 2. Classes of PCB design. What are all the classes of PCB design? The classes of PCB design mainly classified into class 1, class 2, class 3. Class 1 is used for general electronic products. Class 2 is dedicated service electronic products. Class 3 is dedicated to high reliability electronic products such as in avionics, aerospace and healthcare applications. Classes of PCB design: IPC class 1, IPC class 2, IPC class 3. Category: IPC class 1 is used for general electronics or consumer electronics or commercial products. Dedicated service electronics such as laptops, microwaves, washing machine, some mining and equipments. High reliability electronics in aerospace application, military application, radar board are comes under class 3. Medical equipments and healthcare products are comes under IPC class 3 category. Life cycle is short, long and very long. Quality is cheaper. It is good. It is fail proof. Class 1. The first electronic products class is referred to as the general electronics or commercial electronic category. Class 1 is used under general electronics or commercial electronics products category. This consists of boards with the lowest quality requirements and is mostly found in products with an expected short life cycle, such as in toys. Toys and commercial products, calculators, PCBs are comes under class 1 category. Class 2. Class 2 electronic devices encompass all electronics where continued performance and an extended life cycle is required. Compared to class 1, an extended life cycle is required in class 2 category. Uninterrupted service is desired but not critical as compared to the class 3. The service of the product or the service of the PCB should not be interrupted. It should be continuous, but it should not be as critical as class 3 products. IPC class 2 examples include televisions, air conditioners and tablets. Here uninterrupted service is required, but criticality in designing the PCB is less. Class 3. Class 3 requirements must use high reliability electronic components to ensure uninterrupted service. The components used in class 3 product is high reliable products. High reliable components are used to produce the high reliability board, and the material used here is also high reliability material. These electronics are usually the highest of quality compared to the class 1 and class 2. The class 3 PCBs has high quality in nature. Higher quality electronics requires Additional testing and inspection. The class 3 PCBs requires additional testing and inspection which adds cost to the product. Sometimes class 3 product requires gold plating on the tracks for better conductivity in case of aerospace applications. These PCBs also comes under the class 3 category. Terminology used in the PCB design: crosstalk, schematic capture, footprint creation, netlist, placement of components, routing, signal integrity, Gerber, seal screen are the main terminology used in the PCB design. Crosstalk. What is crosstalk? In electronics, crosstalk is considered as phenomenon by which when a signal is transmitted through one channel creates an undesirable or unexpected result on another channel. Here channel is considered as a track. The one track creates problem in another track in the PCB is called crosstalk. It is the inducing of some amount of voltage to the nearby track. The track which creates the problem is called aggressor. The track which suffers from the crosstalk is called victim. Crosstalk is caused by capacitive, inductive or conductive coupling from a part of the circuit to the other. Schematic capture. The very first step of any electronic circuit is the circuit diagram on an paper. These circuit diagrams are then entered into the computer using a program called schematic editor. The schematic editor is the software in the PCB design software that captures the entire circuit given by the engineer. These CAD software are easier to use. The software comes with a unified approach and includes 3D features that helps in easy visualization of the PCB. The 3D views gives us how the actual PCB looks like. That is the feature provided by the software company. The software provided by the software suppliers. Footprint creation is the one of the terminology used in the PCB design. Footprint creation is one of the most important activities in PCB layout design process. Error in footprint creation on printed circuit board can result in costly board respins and projected delays. If the footprint creation is wrong, then it creates a lots of problem. Once the PCB is manufactured, it will not be used. Therefore, we have to go for one more design. We have to redesign the PCB. This shows the footprint of the component. This is a component outline. This is a 30-pin IC. All the dimensions of the PCB, all the dimensions of the component, pad, the pitch, that is the distance between one pin to another pin, all are provided by the data sheet. Footprint dimensions are different from actual mechanical dimensions of the component. Always footprint dimension is more than the actual mechanical dimension of the component in order to fit into the PCB, which should not create any problem to the nearby component. Normally all the components used on the PCB broadly fall under two categories. One is through-hole component, another one is surface-mount devices. The footprint for through-hole component are entirely different from SMD components. For creating the footprint, we have to refer the IPC standard provided by the company. Some of the company provide their own IPC standard, some of the company refer the international standards. Netlist. Netlist is the test file which contains a list of components with their associated footprints along with their interconnections as per circuit in the schematic diagram. In short, netlist is the list of the nets present in the PCB, and netlist shows the connection from where to where it is connected. The netlist is input to the layout design tools to create a layout database. Different layout tools need netlist in different formats. The netlist is also useful for testing the PCB and whether the schematic capture as done by the layout engineer is correct or wrong can checked by using the netlist. Once the netlist is approved, then the PCB designer has to go for the placement of the component and then routing. Placement of component. The designer needs to take a decision where to place all the component, circuitry and logic in the limited space that available on the PCB. The placing of the component and circuitry at particular location on the PCB is very tricky thing. That is depends on how the PCB designer is placing the component. One more thing, PCB designer has to keep it in mind, what is the circuit operation. If sufficient care is not taken, then it can also result in product becoming non-manufacturable. The various parameters that need to be kept in mind when placement of the component are connectors, switches, LEDs should keep at the edge of the board, and while placing the component, digital component has to place far from the sensitive, noisy, sensitive analog components. Digital components are very noisy compared to the analog components. So this is the one of the parameter has to keep it in mind when a PCB designer is designing the PCB. Routing is the next step in the PCB. In this part, all the components that have been placed have to be connected in an efficient manner so as to follow the logic behind the design while not violating the design rule. For routing the PCB, there are certain design rules for tracks like power tracks and signal tracks. Power tracks are routed thicker and signal tracks are routed in thin copper width. The copper width of the normal signals are thin tracks. A router can fail by not connecting the components that are to be connected or mistakenly connecting two terminals that are not to be connected. If two connections are mistakenly connected by the PCB designer, that is not tolerated in the PCB design. Ultimately, at the end of the product has been designed, once the board is manufactured, then the engineer has to cut the track which is not actually required. Signal integrity. SI is a measure of quality of the electrical signal. Signal integrity means the track which travels, the signal travels through the track confined to that track. That track should not create any problem to other track. The track should not have any attenuation or distortion or reflection within the track. Engineering in SI is a very important activity in all electronic packaging. Even while designing the connectors, the SI has to be carried out. Whether the pins assigned to the connector is impedance matched or not is checked by using the signal integrity analysis. The main parameter of concern is SI are ring in crosstalk and power supply induced nodes. Signal integrity. This diagram shows how the signal integrity has been carried out for a particular track. This is a source IC. Out point 18 is the pin number of this IC. 3 is the pin number of this destination IC. and the track is travelled from output pin number 8 into input pin number 3 of this IC. TL is a transmission line track. It is designed for 50 ohm impedance. The rise time of the signal is 2 nanoseconds. When the signal analysis has been done, then the signal looks like this. This is the signal at the destination end. Here, for that we have to insert a series resistance, termination resistance at the source end. Now we are inserting a 37 ohm resistor in order to match the impedance of the driver. The driver impedance has to be matched to the transmission line impedance in case of impedance matching or in case of signal integrity analysis. After inserting the 37 ohm, the signal looks like perfect. One more issue in the signal integrity is the differential pair signal, whether it is signal carries properly or not. Here the tracks are designed for 100 ohm impedance. One track carries the signal and other track carries the return signal. If both the tracks are tightly coupled, if the signal travelled through the track is proper, then the analysis waveform will looks like this. This wave is for signal plus, this wave is for signal minus. Signal plus is the signal carrying track, signal minus is the return path. Gerber is the output file given to the manufacturer. Gerber is a file format used by the PCB manufacturing machines to lay out electrical connections in the form of traces, wires and pads. This file normally generated by the PCB design software like Pads, Allegro, Altium Designer, KiCad. All the softwares can used for generating the Gerber file. Gerber is then sent to the computer aided manufacturing. If the Gerber is found okay, then PCB is manufactured. If the Gerber is found not okay, PCB is not manufacturable. The Gerber file also contains information on the milling and drilling of the circuit board. Drill file and bore dimensions are provided in the Gerber output file. This is the format of the Gerber file given to the PCB manufacturing industry. Board name plus GTL Gerber top layer. Gerber bottom layer is another layer. Gerber solder mask. GBS is bottom solder mask. GTO top seal screen. GBO bottom seal screen. G2L is the inner 2 layer. G3L is the inner 3 layer in 4 layer PCB. .XLN is the drill file is given to the manufacturer. Seal screen printing. Seal screen printing is a common subtractive method that removes copper used in the production of printed circuit boards. The other two commonly used processes are photo engraving and PCB milling. PCB milling is the cutting of the PCB to the required dimensions. Seal screen printing uses etch-resistant ink to print the names. To protect the copper foil, subsequent etching removes the unwanted copper. The etching solution is used to etch the unwanted copper in the PCB. While etching the unwanted copper, the etch-resistant ink is not allowing the seal screen name to erase. Wires. Wires are short form for vertically interconnect access between several layers of the PCB. Pads connect the barrel. The conductive cylindrical filling in the drilled hole called barrel. The pad has barrel. That barrel has to be filled with conducting material. Wires are pads to the component with plated holes that provide interconnection between copper traces on different layers. If the tracks are routed on different layers, to take the connection from one layer to another layer, vias are required. Vias are through-hole connections for the normal double-sided PCB. Vias. Here it shows different kinds of vias present in the PCB. This is a through-hole via which has copper on every layer. This is a blind via which is not visible on the other side. Buried via which is not visible on either side. This is the also blind via. Bill of material. Bill of material represents, BOM represents bill of material. It gives you the list of component present on the PCB. If the list of component present in the PCB is given, the entire cost of the PCB can be estimated so that we can calculate the approximate cost, and it becomes easy for us to order the component. With this we can cross-check the components required for the PCB manufacture. Pads. Pads are used to make connections between components and tracks with the help of solder. Pads are small surface of copper available on the printed circuit board to connect the component terminal. The component terminals are connected to the pads. They are basically used to solder the leads of the component on the board to make the strong mechanical joint. Different kinds of pads are used for surface mount components and through-hole components, as the shape and size of both types vary from one another. The shape of the SMD pad and through-hole pads are different from one another. This is a through-hole pad. The copper area present here is called as an annular ring, and green color is the solder mask. Jumper. Jumper wire forms electrical connection between two points on the printed circuit board. Sometimes while designing the PCB tracks may overlap with each other as we make the connections. In such cases we use jumper wire. Jumper. Solder mask. We have seen the green, red, blue shiny coating on the PCB. This coating is known as a solder mask. Masking is done to avoid the solder which accidentally drops on PCB, and soldering of the component also. Solder. This diagram shows about the solder mask, how it looks like. Questions. The class PCB used for toys comes under. The class of the PCB which comes under used for the toys. The class of the PCB used for toys comes under which class? Class 0, class 1, class 2, class 3. The answer is class 1. It is consumer product. It is commercial product. Therefore, class 1 is used. Question 2. The protective coating used for the PCB is called seal screen, solder mask, epoxy, laminate. The answer is solder mask. Question 3. The list of all the components used in the PCB available in A. BOM, Gerber, Preprex, MD. It is available in BOM. Fourth question. The output file of the PCB is NC drill, Gerber, output data, drill file. Here NC drill and drill file is the output file. Gerber contains all the output data. Therefore, Gerber is the answer. These are all the references.